Hi, I am Victor Shepelev, and I'm happy to be able to talk at Euruko. Unfortunately, I can only talk in recording, but it's a great honor nevertheless. My talk is about 7 things I know after 25 years of development. A few words about myself. I am writing software for about 25 years, and of them, almost 20, or currently maybe more than 20, is dedicated to Ruby, using as my primary language. I've made some contributions to the language itself. I write about it a lot. I maintain the Ruby changelog site. Some of you might have heard about it. Also, I'm kind of principal engineer for US company called Hubstuff, but only kind of, because the most important thing about me is that I am Ukrainian, serving in the armed forces, currently not in combat position, doing other things that I'm better at. And the rest of my activities are happening besides those duties. I joined the army not because I am some kind of militarist or loved arms or fighting, but because I felt that I have a duty to protect my homeland. And it is the same for many Ukrainians. All kind of people are serving in our armed forces, and I have a small personal project of translating poets who are currently serving in our army in English. So, considering this, the actual title of my talk is 7 things I know after 25 years of development and 10 years of war. It is still about development and Ruby, but I allowed myself to draw some parallels with my experience as Ukrainian, and I hope it made the talk richer, nothing too graphic or disturbing, I promise. So let's get to the matter and those 7 things I wanted to share. As the first one of them is that you outgrow every framework. In any area, not only in tech, we frequently rely on various frameworks and foundations to know what to do, what to expect, what's in our future, and how things are related to each other. Say in international relations, Ukrainians for a long time relied on notion of being a sovereign country whose security is guaranteed by global powers, but eventually it turned out it is not so. But back to tech. As a programmers, we frequently, of course, rely on frameworks. As Rubists, we frequently rely on the framework, but I am not about to criticize any particular one. So I have tumultuous relationship with Rails, but I appreciate it as a foundation for many great projects and as a thing that made Ruby popular and still move us forward thinking in the language. But my point is frameworks provide us room and boxes to put our code in and to feel confident with only implementing the business logic inside those rooms, boxes, and limitations. But we all know eventually as code grows, we have more concepts and then even more, and some of them are provided by updated versions of your framework. Some of them are from third-party libraries. Some of them you implement yourself. But however we extend the general number of concepts we rely upon, something always sticks out. And like a fractal, every particular concept starts small and then grow into framework of its own. Like common nowadays, callable objects, call them service objects, operations, actions, and interactors. They have many names. This is a simple idea. When you introduce it, it might seem as a small step you need to achieve completeness of the mental model of how things are related in your code base. And then there are new requirements and new use cases, and eventually you have a few dozens of DSL options to define a small service object or callable object. And then some case sticks out anyway, not fitting into any of the previous definitions. And if you don't handle things that sticking out of the conceptual model, you either have very bloated concepts like huge controllers, huge models, huge service objects, huge decorators, or you have some garbage bin in your code base like lib folder or services folder where everything that sticks out goes and eventually nobody knows what is there. So basically, to handle this, you should always be ready to make your own architectural decisions, regardless of the framework you rely upon. But there is a problem. And the second thing I'm sure of, that whole patterns, methodologies, and approaches also fail you and get outdated. Like, again, back to Ukrainian experience, the whole international security architecture became laughing matter at some point, and international humanitarian structures prove themselves useless. And human rights defenders defend anything other than human rights. As a developers, when we make a decision, we might rely on some methodologies, trusted approaches, books, pattern, or funny mnemonics encoding simple principles. As code grows, project matures, as industry develops new opinions, as challenges change, a lot of doubts and questions emerge. You might learn that inheritance was an idea that is good only in textbooks. You might hear that the whole object-oriented programming have failed us. You start to doubt whether active record is a good pattern and viable approach, or maybe you need passive entities and repositories and draw some inspiration from functional programming. You might be reminded that solid is an acronym coined for marketing purposes just by one person, and it groups useful but vaguely defined and contradictory principles. And in general, for any common approach we know, for anything that we learn in school or later, there is a lot of articles and even books arguing about its uselessness or even harmfulness. And there are then further counter arguments and counter arguments to that. And eventually, we discover for ourselves more newer, more high-level guiding principles like domain-driven design, which follows very same idea of isomorphism of our domain, which we implement, and its coding representation. But it still leaves many blanks on design decisions, like when small domain concepts require huge algorithmical implementation, and where do you put it if in domain it's something small, and what do you do when big domain concepts are very small in code, and those discrepancies grow and grow. And also, DDD introduces a lot of new terms which people love to turn into literal classes. So eventually, beside your models, views, controllers, decorators, representers, you have also entities, aggregates, bounded contexts, and so on and so forth. Or sometimes we might talk about hexagonal architecture as a more high-level approach, which is notable for the fact that it never explains why is it hexagonal, and also for leaving the design decisions of the whole core architecture for yourself, which is not to say it doesn't provide some useful principles, but still a lot of questions remain, a lot of uncertainties. So those might help, but eventually you are still on your own in designing new things. Why is it so? So the third thing I'm certain of, that scale only grows with time. This is true about many things in the world, and it is also quite trivial statement, let's be honest, but it has frequently overlooked consequences. Like, imagine any Rails app you ever maintained for some time, like maybe a year or several years. I think you probably agree that all it did was growing. We live in a capitalistic world where you need to run fast to stay relevant, whether it is some new tech like switching old application to single page application or vice versa, or supporting some mobile client, or extending your market share to customers of smaller or bigger scales than before, or trying to adjust your market fit without losing old customers, or just linear growth, which poses new challenges. Whatever happened, there was more code, more tables, more endpoints, more tests, more everything, just grows. As an example, we might look at the GitLab open source code base, which at first looks like your regular Rails app. Initially, it was like just an UI for collaboration around code on top of Git, like almost trivial thing. But now GitLab is many things. If you look into its main folder, you'll see a bit more things than in smaller Rails applications. And then if you go into app folder, it has a multitude named concepts. Those more standard for Rails, those more or less widespread, and also some custom ones characteristical only for this code base. And then if you investigate into one of those, you see more code and note that the last screenshot only goes to letter C. So it's like much more. Maybe not all of our projects are at scale of GitLab, but talking about any commercial and many non-commercial projects, eventually you'll need things like reports or notifications, better fine-grained role management, maybe payment systems, maybe some new APIs, maybe bulk operations, some business analytics, and so on and so forth. The simple yet frequently overlooked consequence of this constant growth I was talking about, it is absolutely perfectly natural that your old ways of handling problems would stop work eventually, that you overgrow your framework, that you overgrow your methodology, that you find new methodology and outgrow of it too. So basically the way of thinking about several dozens of classes, 5 models, 3 controllers, and so on, and the way of thinking of several thousands of classes, they require not quantitatively but qualitatively different approach. So what do we do then to survive through all this? I have answer. It's not a definitive one. It's just one approach, and it might seem like somewhat paradoxical one. So my answer is pay attention to singular stories of your code base. When working with any feature in our software or with any particular task, when you implement something, when you fix something, when you try to understand something, we always have some narrative to follow. There are some causes and consequences. There are inputs, outputs, transformations, effects, and it all can be told and followed linearly. But in many modern code bases, jumping through layers and conventions and discussing the bigger picture, we frequently losing those particular threads of particular stories, what goes where, what is connected to what, and then we lose the big picture. A small illustration. Once upon a time, a few years ago, I was trying to add a new feature to Robocop. It didn't work it out, but for unrelated reasons to the story. And I had this big aha moment when I spent like a day trying to understand an algorithm of detecting which cop disabled directives were redundant. And it was split in several dozen 2-3 line methods, very simple, very readable, each on its own, but eventually I rewrote it in what you see in half a screen sized method, which didn't match expected complexity metrics of Robocop. Here is, by the way, the fragment of original algorithm, but I don't have a screen big enough to screenshot the whole thing. That's not about badly written Robocop, because Robocop is awesome piece of software. It's very helpful, it's very well designed, and it is one of core of our community. But about some deeper approach differences, like splitting everything into ultimately small methods, extracting every non-trivial condition to a predicate is a very widespread approach in Ruby community, and the default complexity threshold of many linters and EDS just reinforce that. But it leads to what I'm talking about, to losing a thread of a story that happens. As a counter opinion, in Hubstaff, we have this fragment in small coding rules document, and our small coding rules document is quite big, and I'd say it as important as a whole architecture document, just for the reasons I'm trying to explain. And this fragment underlines the idea of trying to put everything together as a story first, and impose architecture particular only after that. The single method is not a key here. It's just one representation of a story. What is a key is point of view from which focusing on exposing what's happening here with code is the main goal. It leads to discovering of good names, of good structure, of which concepts are related and which are not. And it happens much more reliably and naturally than just trying to sit and come up with an architecture of implementation of something which frequently, when implemented in code, turns out to be just inside out. Most of the time, trying to define some new architectural decision starting from the big picture is stuck with the problem that there is actually no big picture in big software projects. There is no simple truth or simple set of rules that explain everything. Anybody who tried to make a class of flow diagram of a mature project knows that you have just an insane verb that explains nothing. It is all just a bunch of interlinked stories, each of them told on its own, and it's like a garden with passes through it, not a concrete skyscraper. And it's true for most of mature projects. So why those stories are so important? The fifth truth that I believe that I learned through my career, that the goal is not beauty or good architecture or readability or name any other thing but truth. It emerges from listening to the real stories. One might say that truth is a veiled word when talking about software architecture. We typically, the closest we get is like whether our mental model matches the expectation of a customer or something like that, hiding behind the big words. But in my persuasion is that on an intuitive level, all our principles and methodologies are introduced as a way to search for some truth, like object-oriented programming was invented in simpler times in a hope that we can like model the whole world in objects that correspond to every concept we know. Like behavior-driven development was introduced as a way to honestly try to code the requirements to some software piece before even trying to implement it, and so on and so on and so on. Our problem is we turn any good and imprecise idea, and each of those are good when they are imprecise, when they are inspirations, when they are ideas, but we take them and turn them into disciplines. We formalize them, and eventually then instead of trying to truthfully mirror the problem to code, we replace it with just rigorously following some rules we invented for ourselves. As a small example, Ruby's community once leveraged the language's expressiveness to invent an incredibly powerful testing DSL named RSpec. But then eventually the same community persuaded itself that tests shouldn't be expressive, that they should follow some rules of the most primitive code possible. There are many recommendations like that on the internet. As a consequence, many Rubyists are taught to write tests that are more verbal than the coded tests, sometimes orders of magnitude more verbal. And they hate it rightfully and are forbidden from even dreaming of thinking it could be another way. But, well, it actually could. Whether you like this example or hate it, and I know that opinions might polarize, but I really hope that you can see at least that my one point here, that this example is telling the story of expected behavior, telling it clearly and truthfully, and attempt to make it work how we want to write it. Also illustrates the effect of storytelling approach has on the thesaurus we use, because to make it work, you'll need a new high-level abstractions like new match or create record, which is non-standard. And once defined, they help to make many other tests more expressive and more clearly explaining the intention. But it is a well-known fact that approaches like this frequently meet with a fierce pushback. And here lies my sixth thing. Trying to stick to true stories might be very lonely experience. First of all, because people have their big pictures, and the first thing that they'll expect from your story is to see how it fits in their big picture. And if it doesn't, well, that's worse for you. So when trying to sell the approach which focuses on what's really going on in the code, on telling stories, on trying to express a lot in a screen of code, be it on code reviews, on pair programming, or discussing style guides, one might meet the reactions ranging from total indifference to active hostility, best case, you are trying to explain why something is better to write in this one line instead of those 10 lines, and somebody will tell that doesn't matter. My code works. Let's merge it. And worst thing that there would be a huge discussion somewhere on Reddit that this code is not friendly for novices or something like that. The reason I believe is that looking for truth is about adjusting your mental models constantly and questioning your experience and expertise. And in general, people, and especially established professionals, and especially software developers, they aren't up to challenging their own mental models. I mean, we might change tools every day or even frameworks, but if you have some persuasion from maybe even from IT school about some way of writing code, when or some small habit, when it is challenged, you are not up to listen. One might notice that lately in industry there is a lot of strong sentiment against smart code, expressiveness in general, expressive languages, or broader about unimportance of any particular ways of the writing code, because we are all here like grown-up professionals and all business solutions and architecture and such stuff. And as an offspring of it that I want to touch, there is lately a strong sentiment against code review in practice. Like, I get it, I do. In general, while solving problems, people prefer to write, not to read a lot or edit in what's already written. So this leads to a sad state of things when the sane and useful practice of code review turns into some laborious formal duty for both participants, and nobody knows how exactly it should be handled. Should we discuss the code? Should we not discuss the code? Should we only stick to obvious bugs, or should we discuss every comma, or what? And eventually it is bad-mouthed as a harmful, meaningless way to waste time and establish dominance, and let's trust each other and just match to master. But in my view, reading and discussing each other's code is the only way to make sure the story you are telling makes sense to others. That it doesn't contradict other stories, that it doesn't misuse a common thesaurus to say things that shouldn't be said this way, or just simply untrue, even if they look like architecturally sound. This is code reviewing and discussing code and thinking about how to express oneself in code. I believe this is a deeply humane activity, and nobody will persuade me otherwise, which lead me to my last point, kind of sentimental one. The last point is we should never give up seeking truth, however uncomfortable it is. We should search for knowledge. We should constantly adjust our worldview if new knowledge contradicts it, we should ask. We should rewrite outdated code and not grow fond of concepts that turn out to be not that useful. We should drop faulty hypotheses and whole unreliable foundation. Software author is, first of all, a writer, and that is also a thing I'm deeply assured of. And they are a person that ideally stands upright and says, that's what I know for now, and that's my best attempt to explain it. Having this stance, preferring it to anything else, to hiding behind terms and concepts and authority, it is an invaluable quality for long-term project success, or basically for any long-term human activity success. This is the most important thing I learned, probably not much for a career this long, but that's where I stand personally and professionally. Thank you. I hope to see you all in person one day. And please, even if you not remember this talk, remember to help Ukraine. Thank you.